This section, what we're going to look at is we're going to look at time-based or time-driven activity-based costing and looking at it through a lens of utilizing Microsoft Excel. So that's what we're going to look at here. So let me go ahead and share that with you. So the first thing is we're going to use time-driven activity-based costing to assign costs to cost objects. So we have some key concepts. So time-driven activity-based costing, or TDABC, overcomes two important limitations that accompany the activity-based costing, or ABC model, that we spoke of earlier. In that TDABC does not require extensive interviews with employees, does not require employees to self-report their idle time, and it helps companies to estimate the financial impact of aligning capacity with demand. And again, looking at Baxter again. So we're going to go back and look at our example with Baxter Battery. Now, Baxter would like to improve its understanding of customer profitability and capacity utilization, and will use TDABC to analyze its customer service department labor costs for the reasons that are provided on this slide. And so it is to assist in better understanding the three main services that are provided to customers, and they require significant labor costs. And we want to know what the labor costs are and how are we doing for customer orders, for design changes, and for customer assistance. We want to have a better understanding of those areas. Now, the Excel spreadsheet created summarizes three types of data inputs for Baxter's TD-ABC model. First of all, the resource data, which includes the number of employees in the department, the average salary, the number of weeks in a year, the minutes available per week, and the practical capacity percentage. The activity data acknowledges that employees are not serving customers 100% of their available time, right? Because there's going to be time where they're going to be doing other activities. There's going to be time when they are doing other things. And then also our cost object data, which includes the number of orders that are processed, customer queries, credit reviews for 3 select customers, and then for all customers. And so again, looking at this and breaking this down. So we look at the resource data, which includes the number of the employees in the department, the average salary of the employee, the number of weeks in a year, the number of minutes per week, and a practical percentage. So we see here that they have 15 employees within customer service. The average employee salary for somebody that works in customer service is $42,300. They work every week of the year. They don't take off, a week. Some businesses will do that where they'll close like a week at Christmas, a week at Thanksgiving, whatever. And this company doesn't do that. And then the number of minutes that are available per week is they work 40 hours a week. So 40 hours times 60 minutes, you get 2,400 minutes total. And the practical capacity of what they're doing and how they're serving is 75%. Then the activity data bases upon that they have the minutes that are required for each activity. That's why we broke it down into minutes. So the number of minutes it takes to process a customer order is 30 minutes. It takes 90 minutes to conduct a design change, or we spend about 80 minutes of our time providing customer assistance. And then we can break it down. The cost object data then breaks it down, and we do it for our 3 largest customers and then overall. So we have the number of customer orders processed for Acme Auto, Car World, and Auto Services, and then all of our other customers. the number of design changes processed, and the number of customer assistants. And with that, we can use that to be able to extrapolate and calculate some things. So now Baxter uses a 3-step TDABC process to assign customer service labor costs to 3 of its customers, which are Acme Auto, Car World, and Auto Services. The first step is to divide the total cost of the resources supplied, which is $634,005, by the practical capacity of the resources supplied, which is 1,404,000 minutes. So take the amount divided by the number of minutes, and that gets us the cost per minute of resources, which is 45 cents a minute. And we take that. So the total cost divided by the total capacity gets us that, the per minute. And then the second, and we see that. So then the next step then is to calculate the time-driven activity rate for each of the 3 activities by multiplying the minutes per unit of the activity by the cost per minute. And so we just take, so for example, for customer orders, we would take 30 times 45 cents, gets us that it costs, should be $13.56 for each customer order, $40.67 for each design change, and $36.16 for each customer assistance. The third step is to assign customer service costs then to those 3. So we can take those rates that we did earlier, multiplied by the number of what we did for those customers. So we see, for example, that for Acme World, Acme Auto, that we had 20 orders that were processed. So the total of that by how much each order was is $271.15. 8 design changes by the cost per design change, which is $40.67, is $325.38. And then the number of customer assistance requests, which was 10 times 36.15 is $361.51. So we add up those 3 numbers, $271.15, $325.38, and $361.54, we're going to get $958.08. So we can do that for each company. So we can do that for Car World, we can do that for Auto Services. So the total for Car World cost of providing customer service is $1,211.15. For Auto Services is $1,188.56. And then what we can do now is use the time-driven activity-based costing to analyze our capacity. And so the next few slides, we're going to look at the 4-step process that Baxter Battery can use for capacity management purposes. It focuses on all of Baxter's customers rather than just those 3 initial customers that we're looking at. So what we can do is the first step is to calculate the total used capacity in minutes, which is 820,000 minutes. So again, taking the total number of customer orders, multiplying by the number of minutes it takes to complete, gives us 300,000 minutes. It's devoted to customer orders. We can do the same thing for design changes and for customer assistance. And so we get that we spend 820,000 minutes servicing these other remaining customers. Step 2, then, we can calculate is we can take all of that and figure out what our unused capacity is. So we know that we said that we have 1,404,000 hours that we have available. And so our total customer service minutes that we are using is 820,000. So we have an unused capacity in minutes of 584,000, meaning that we have time available that we're not utilizing. Now, the third step translates this unused capacity in minutes to the unused capacity in terms of the number of employees. The unused capacity in minutes gets divided by the practical capacity of one employee capacity to arrive at the unused capacity of employees of 6.32. So we take the number of hours divided by the practical capacity per employee. So again, 40 hours a week times 60, and then only 75% of that. So we get then that we have unused capacity in employees of 6.24. And what this tells us then is that calculates the financial impact of matching capacity with demand. So if we were to eliminate 6.24 employees, it would leave the employee short-handed. So if we round down then to 6 employees, given that the average salary per employee is $42,003, the impact on expenses matching labor capacity with demand would be a savings of $253,008. So this just tells us if we have more employees than what we actually need in order to meet the demand or not. And of course, we can decide then if we want to lay off these 6 employees in order to match the number of employees that we have with the demand that we require. Or be better off, maybe we don't lay them off, but maybe we do some other analysis and we plug them in some other areas where they're maybe needed in a different role. Now, this next set of what we're going to take a look at is showing some what if analysis that we can do using Excel. And we can play with this a little bit in order to figure out what's going to happen. So the strengths of this entire methodology include that it's easy to update because it doesn't require employee interviews. It quantifies unused capacity costs in an objective fashion. It doesn't require employees to self-report their own idle time, and it helps companies to estimate the potential impact of aligning capacity with demand, particularly with respect to step-fixed resources such as customer service employees. So what we can do is do some what-if analysis. And so in this case, if we say that we have reduced our number of employees from 15 to 9, and if we reduce our average salary from what it was to 40,000, then we're able to calculate then a different cost. So then our cost rate changes to 43 cents per minute. And then from that, if we plug that in, it's going to reduce our cost of providing each one of those activities, the customer orders, the design changes, and customer assistance. It's going to reduce those costs. And then it also then how it would affect for those particular customers. And you could do the same thing for overall what it would affect.